Very good morning. Today I would like to speak to you on the embedded system which has been prescribed for the third years, and it has been very, very essential in the modern days where the extensively used embedded systems have been achieved. The technological advancements have made the life very easier by making use of embedded systems. It has been very, very important in modern days where one should know how to use the embedded system. It has been a practice nowadays that the embedded system should have a software and hardware together with mathematical functions. And here the embedded system has been used only for a dedicated function. So if you see the definition of the embedded system, the system is a special purpose computer system to perform a dedicated function. Or we can also say that it is specific systems which contain hardware and software tailored for a particular task and are generally part of larger system. So if you see the block diagram here, any system should have a software and hardware with some inputs and outputs with a user interface and then linked to other systems like the external memory. It is very, very important to see that the block diagram which shows a clear explanation is that what are the components involved in this. The components, if you see here, one is input devices and which are drivers. Then a very important factor is a processor, which has been used nowadays with different generation of computers. Plus, we should have programmable memory, where we have to store the data as well as the codes. Therefore, it has been called as a programmable memory, and data memory has been associated with it. Serial communications has been essential because we have to send the serially the data to the CRT and display devices. So there should be an interrupt controller which has been used for interfacing, and it has been event recording has to be done with the interrupt controller. Interruption, you know that it has been when a process is going on, suddenly we can stop and then execute or some other work and come back to the main program. So therefore, the one more thing is that the parallel ports have been available where we can connect the printers such as which can take the hardouts for you. The output interfacing driver circuits has been essential to go for a display system, which has been very, very essential nowadays. Added to all these things, we need to have a power supply, a reset button, and then the oscillator circuits with the application specific circuits. This is the components which has been used in the embedded system hardware. One of the first recognizable modern systems which has been used by the MIT Instrumentation Laboratory for their project inception, Apollo Guidance Computer, which was the riskiest item in the Apollo project, as it employed the then newly developed monolithic integrated circuit to reduce the size and weight. As you know that the integrated circuits have been employed to reduce the cost as well as the size of the chip. An early mass production embedded system was in Autonautics D17 guidance computer for Minuteman missile received in 1961. And Minuteman 2 went into the production in 1966. D17 was replaced with a new computer with a first high volume use of integrated circuits. So this has been a history where you could look at it. And further, you can see the Apollo guidance computer was a digital computer produced for Apollo program and which has been used as the Apollo command module in the lunar module systems. The automatic gain control provided computation and electronic circuits for guidance, navigation, and control of this spacecraft. So if you see the characteristics which has been very, very important, what I have been telling you all these days, that the dedicated system which has been called as the embedded system. Suppose I have a power application where I want to simply monitor the voltage and currents, and they do not have to have such sophistication there. So I can have a special purpose computer which has been called as the embedded system, which has been having a separate software only dedicated for power applications. Such things have been used nowadays. So therefore, it is application oriented embedded systems have been available. So therefore, the particular software has been built into the system, which will be used for embedded system. So include processors dedicated to specific functions. So therefore, the processor has been essential because we had performed so many operations with synchronization and concurrency. To achieve this, we need to have a clock, which has been a main important factor here, that depends upon the generation of processor, first generation, second generation, third generation, like that. So you can have such a process here. Represent a subset of a reactive response to external input systems. So therefore, there should be some sensors which will be used here to response way so that the system can be operated to our satisfaction. Contain real-time constraints. You know that the computers have been used for online or real-time or offline. But we have been always look at it a real-time constraints where the system can be employed for real-time, where the systems can be powerfully used for our purpose. So therefore, real-time in a sense is that whenever a process has been taking place within a system should be synchronous activity at the same time. Include requirements of a span or the performance. So to have a customer satisfaction, the system which has been designed and developed should give a satisfactory performance. So performance in a sense is that to satisfy the needs of the person for which it is employed. Just like for example, you have a washing machine. So washing machine has to give a good performance for to satisfaction of the customer. So therefore, next one is reliability. So reliable means have been reliable in a sense is that it has been operational perfectly to my satisfaction. So it can live for long. So form factor. Another factor is that the form factor is very, very important as one of the characteristics. If you see the performance, I said the performance in a sense is that we have been using a various technologies. As you know, in the older technology, we have been calling as a TTL logic and also ECL logic, which has been a faster in nature in the gates. Therefore, the further CMOS technology has evolved further and further into this point where the speed of operation has been improved and increased. The computer optical improvements. When you say that the RISC superscalar or RAID computers have been come into market. So RISC in a sense is that the RISC is reduced instruction set computers. What is by reducing set? What I could see is that the not instruction are reduced, and it is just in a very important fact is that the instructions are reduced in a sense is that the instructions have been scaled down to the level of a hardware which has been extensively used. Just like you say in and out, in any program if you take, there should be in and out instruction has been very, very essential. So these things have been realized hardware, not with software, so that the performance will be much improved and it is very reliable. Similarly, the price. Price depends upon the simpler development and the higher volumes. Therefore, the CMOS VNS technology has been employed where you can have the power consumption is minimal, and you know that all the TTL logic or anything has been working on the principle of the VCC. VCC can be reduced to a level of 3.5 or to 1.7 volts so that the power consumption can be minimized for further and further. So therefore, the components which has been used, lesser components which minimize the cost of the system. Similarly, you could talk about a volume. Volume in the sense is that the device, when you go for a VRS technology, you can able to produce so many components integrated to the same substrate, where it can also get a more volume to a smaller area so that the cost can be minimized. Like that, we can think of the embedded system, why a embedded system has been extensively used. So if you see here, the difference between the embedded system, where we call it as a microcontroller instead of a microprocessor. So microcontroller means we have been using a washing machine where you have to rotate the drum and then anti-clockwise. So therefore, we have a controller here. So controlling action has to perform, whereas a microprocessor will have mostly a mathematical operations and then some sort of a minimal controls can be employed. But whereas in microcontrollers, it has been a very advantage is that the memory has been built in into the CPU itself. So there is an advantage where a smaller memories can be built in into the CPU itself. So it's like that the controls have been actually used in the embedded system. So if you see the application areas where the signal processing system, I said already a real-time system, and where the DVD players and medical equipments which have been essentially used. Nowadays, the pixel processing has come into market. So as you know, the medical equipment has been used to go for the very sophisticated operations where the signal processing will be essential, which will be using the purpose of an embedded system. Similarly, we talk about distributed control, where the network routers, switches, and firewalls. All these things have been very, very essential because of the communication network has to be powerful nowadays, where we can have a distributed controls at different points with different switches and then firewall protections. So therefore, similarly, a small systems also have been used, as you know that mobile phones with an example for a smaller system which has been using a embedded controller. Home appliances and toys, smart cards, MP3 players, PDA, digital cameras, sensors, PC keyboard and mouse. These have been a smaller system where I can think of about the embedded system where it can be built into this point. So modern years, when I talk about up to 100 or more processors have been employed. Cars. So many cars have different controls. Even with a driver, I can able to drive the car because of the embedded controllers have been employed into the different cars like the engine control, ABS system, automatic braking system, emission control, diagnostics and security systems, and access like the doors and windows which can be opened automatically with the remote points. So like that, all this modern technology has been built into this point as a modern controllers, which has been used here with the embedded system. So if you see further and further, I could say that the embedded system applications, if you look at it, consumer electronics like cameras, cam recorders, consumer products such as washers, micro ovens. Similarly, the automobiles, if we talk about a locking braking system, engine controls. If you go for industrial process controllers, avionics and defense applications where actually used embedded systems, or computer communication products, which has been printers, fax machines, etc., are emerging multimedia applications and consumer electronics, a cellular phone and personal digital assistants, video conferencing servers, interactive games boxes, TV set-top boxes, etc., with the multimedia. So increased reliance on wireless and hardware integrations. So it has been, now you could see that wherever you have been going for embedded system, if you talk about all these applications we see, I could see that it has been serving for a dedicated purpose. So whereas I say computer has been general purpose computers, but whereas embedded system is for a dedicated application for which you are been using it. So if you see further the characteristics of the embedded system, a typical characteristic one is that they performance a single or tightly knit set of functions. Number two is that increasingly high performance and reliable constraints. Power, cost, reliability are the often important attributes that influence design. I already said how a power is very, very important is that the cost of the power, because if power is been, if it draws more and more current, it gives lots of dissipation problem. Therefore, we have to minimize the power. So minimize the power, we have to draw a lesser current. So to draw a lesser current, we have to reduce the VCC to a minimal threshold so that it can able to operate. So like that, the when you could able to get reduce the power, it is a very, very important factor for us because the power dissipation problems will be minimized. If you see the application-specific processor design can be a significant component of some memory system. As you know that the advantage is that the customization yields a lower area, the power, and a cost. Wherever you think of a electronic circuitry, we've been interested in power. Number two is area. Number three is cost. So therefore, if you see the area where I can integrate more and more number of content in a smaller substrate, and it's been very, very essential for me. Similarly, power. Power I cannot sacrifice because the heat sink has to be provided, which will design will be very, very problem. So therefore, the heat sink design can be minimized by lowering the current thresholds. Similarly, cost. Cost depends upon the technology as well as the number of products produced. If you see the disadvantage side of this, any system, if you talk about, there's a pros and cons. And among these, we have to see the advantage side is more and disadvantage is less. If you see the disadvantage side here, the higher hardware software development overheads, design of compilers and debuggers may result in delayed time to market. Because why I say this is that as the technology is advancing, as you know that so many languages are coming to market. Accordingly, we have to design the compiler's design and also the debuggers so that the program will be very nicely fit into the embedded system. So therefore, this takes some time for me to get into the market. So that's the only thing that as the technology is advancing, getting a product in the market will take some time. That is only a disadvantage here. Otherwise, if you see the power, if you see the area, if you see the cost, it will be very, very good. So therefore, I can synchronously say the compact T. One is interface is very important. Interface between what? The external world to the processor. Number two, the complexity is very important. As you go for technology advancements in VLSI, and the complexity will be definitely increased because we have been integrating and embedding more number of components into the single substrate. Then the platform. A platform means it is a CPU which has been used here. Is it first generation CPU or second generation CPU like that? That's been very, very important because all the generation of computers depends upon the CPU and its clock is very important. You know what is a clock? Clock has been a very, very essential to have a synchronous activity among the events within the processor. The peripherals has been very important because the external world needs peripherals like a printer, a display devices, all these things. Okay, so therefore the peripherals have been important. The tools which has been essential to get into the embedded system. And then the reliability is another aspect. What I've been talking about is there. If it's unreliable, nobody will prefer it. So it should be reliable. The system which has been developed and designed should be reliable for work for a longer time. Then I say it is reliable. The next volume. Volume, I said already that the production point of view, a number of pieces produced will make a volume larger and larger so that the cost can come down. If the volume is minimal, then the cost is higher, goes high. So therefore, the volume is another factor where I could think of. Therefore, I can say that interface, complexity, platform, peripherals, tools, reliability, and volume has been essential characteristics of an embedded system. Now I just take them one by one and say that interface. Interface between what? Between a user and a no user. Okay. So therefore, if you say no user, direct one task. If you went for full user, user for defined PDS. So therefore, the interface can be between the mission to mission or human interface to a mission or mission to human interface. These are the things where I call to the interface. Interface gives me a compatibility was a speed between two systems. So human may be slower than the system. So therefore, the clock which works will be compatibility will suffer. Therefore, we need to have a buffering in between as an interface. Next comes the complexity. I already said that complexity has been when you go for more and more designs, more and more compactivity, because for a smaller area, I have to integrate more number of components. These are correction effects here. So therefore, I can call complexity, which will be dividing my system into a simple system and then a complex system. If you say simple system, use buttons, small characteristics, digital-only displays like a simple menu system. Complex systems will be connected to a network, a touch screen, real-time constraints, part of a critical operation. These are the complex. So the touch screen definitely a complex because it is such a sensitive sensors have been involved here. So therefore, I can say it is complex. Similarly, real-time systems, real-time, and I said that a concurrency between the events has to be attained. Therefore, there's lot many constraints will come into picture there, like a time constraint or a amplitude constraints. So these are the very important factor where I look into so that I can divide the complexity of my system into a simple as well as complex. Third one is that a CPU platform, what I've been talking about. I already said to you that depending upon the processor use, therefore I can have an ARM processor, I can have a MPS, 86 processor, controllers of 8051, etc., etc. So therefore, which generation of computers will be employed speaks to me about CPU platform because that sort of software has to be designed. If you take 86, I need assembly together with the compiler. If you go for all processor, I need to have its own compilers. So like that, depending upon the processor you select, or I go for a 486 or a Pentium chips, it needs its own language processors so that I need particular compiler to translate my program into a coding point. So next, the desktop computer market is limited to just a few architectures. So as you know that this has been limited to a few architectures only. Then the PC 104 is typically based for small and low volume embedded system design. Uses an embedded system real-time operating system such as macro, C and OS2, QNX and VX workstations. So therefore, when we talk about the real-time of the system, the operating system which is being employed should also work in real time. That's the meaning of it. When I say embedded system, real-time operating system, so operating system which has been built into the system should also takes care of the real-time applications. So therefore, particularly the OS2 or workstations have been designed nowadays, which has been perfectly working for embedded real-time applications. Next is very high volume embedded systems uses system on chip, specific integrated circuit as ASIC. Okay, so specific integrated circuits have been used for the purpose of the design of the hardware. CPU core was purchased and added as a part of the chip design. Okay, so therefore these are the few points I can look at it. The CPU platform, which has been very, very important because before you go for a CPU selection, one is to aware of the languages used for the processor and also the compilers available for the processor and also debugging tools available for the processor so that I could be able to see a suitable CPU for the particular purpose. Coming to peripherals, if we talk about, I said already that the human interfaces with a system. So therefore, I need to have some communication media where the compatibility will not suffer. I said the compatibility in the sense is that the speed of operation. So one device may be slower, CPU may be faster, CPU may be slower, the device may be faster, like that. So therefore, I need to have established communication buffers or a peripheral so that the interface has to be designed properly so that there should be any mismatch between the user and the system. So therefore, the serial communication interface has been very, very essential to adapt for display devices, and also the universal serial bus, which has been very, very essentially used, where it does the controlling of the baud rate, what is speed of operation of the sending the bit to the other network. Similarly, the network, when you talk about, there's the Ethernet control area networks are available with us, which has been extremely used nowadays for sharing the data. Similar timers have been there, PR phase lock systems, the capture and compare of timing processing units. I said a timer has been very, very essential because it has been worked with in conjunction with the interrupt controllers so that the synchronization can be achieved a very, very finest way so that there will not be any clash in the system. It will be neatly channelized to perform the event of operations. Similarly, the general purpose input-output bus is available for us, and unlock digital and digital unlock converters are available. So if you see, the most of signals available here is in analog nature, which has to be converted into digital form. Similarly, after the digital processing has been taking place, again it has come back to analog signals, so that the real-time world looks at it, the analog signals only. So only digital operation has been employed because the computer has been digital nature, where it accepts the information only in the digital form. Therefore, there's necessity for you to go for changing the converting analog signals into digital form. So therefore, I need to have everywhere the ADC and DAC is very essential, which has been very, very important also. If you see the tools available here, the embedded system designers use compilers, assemblers, and debuggers. You know the importance of compiler, you know the importance of assembler, and you know the importance of debugger. But at the same time, I would like to clarify for something to you is that the assembly language has been preferably used because the language to be essentially used here is that suppose if you take a C language where the C can be integrated with the high-level language with the assembler. So therefore, it does the operation of, I already said in the beginning is that in and out instruction has been stepped down to a level of hardware. Is other if you go for software, the best suited is a C language where I can able to use both assembly and high language together so that it does efficiently well to minimize my CPU consumption time. Because when I talk about any system design, I've been interested in the CPU time consumption. Okay, I cannot wait for longer and longer time. I need a compact design where the CPU can be executing the program into a simplest possible time. So therefore, I have a compiler or assembler or debugger which suits to my use where the CPU time has to be minimized. Coming back to these utilities to add checksum or CRC to program, because when I program a device in the form of codes, I have to check the codes have been stored properly or not. So I have to take a number of bits of binary for a checksum so that the stored data will be valid and it has been useful. So therefore, checksum has been very, very important. Similarly, cyclic redundancy check is also we use for the programs. So these are the utilities to add to my program. Similarly, the emulators replaces the microprocessor with a simulated equipment. Okay, emulators have been used because I need not to have, when I've been developing a program, every time I cannot use that particular chip. There is a common emulator where only CPU can be changed depending upon the program availability. So I can use the same emulator, 86 processor, 186 processor, through to 386 processor Pentium chips. So like that, when a CPU can be changed, I can develop my software program on the emulator. Once I have been satisfied with the performance of the system, then I can design it to the scale down to the hardware and software designs. Okay, so these are very, very important what I could see, look at it. Then the reliability issues. System cannot be shut down for repair. Okay, suddenly many people have been working on that. Suddenly I have somebody power off the things. Restarting will be dangerous because when you make a shutdown, there are chances for a software to go off. So therefore, the lot of bugs will be entering into the point. There will be a malfunctioning of the system once you start it out. Okay, therefore, don't do at any time a shutdowning before going for. Be clear about it that what you are going to do. Shutting down is not advisable at any time before you go for a repair. The solution involves subscription with a spares. Okay, system must be kept running for safety and monitoring reasons. So these are very, very important because when you power off this system suddenly for repair, reliability issues will come into picture. So that's what I want to stress here, the reliability issues where the system has to be reliable for a consumer point of view. So once next, the last point I've been telling you to you is volume, high volume and low volume. When I talk about, I said minimizing the cost. I said if your production is more, I can minimize the cost. If the production is less, technology has been new, then low volume will come up and the cost will go off. So therefore, these are the things where I could see a volume in a sense is that the cost per production is very, very important because nowadays people expect a cheaper values now. So the cost should be minimized. So that is the point of view that I want to produce a lot of production so that the cost can be minimized as a major factor. So if you see now the essential components and considerations, at last I could see that the essential components, one is a microprocessor, a DSP core. Next, the sensors or a transducers. Similarly, I have converters, A to D and D to A converters. Further, I need to have actuators. Then the memory on chip, off chip has been essential. Communication path with interfacing environment, like that. Then the essential consideration when you talk about is response time. I said a response time has been how fast your system can respond for the inputs available. So therefore, it's narrowing down to a real-time system. Similarly, the area, the cost, the power, the portability. I have not talked about the portability so far. The portability has been very, very important factor here. Wherever I can move my system, I can move it. So that's very important for me as portability. Fault tolerance. Fault tolerance has been very, very important nowadays that the how to minimize the system faults. So I have given here some list of ES devices, embedded system design flow. One is a modeling, a system to be designed and experimenting with algorithms involved is modeling. It can be mathematical modeling or can be a physical modeling. So when I talk about modeling, a mathematical modeling, it involves all the algorithms. When it's an algorithm, it's been very important for me because the CPU time consumption depends upon the algorithm which you select. So therefore, I give more stress for algorithms so that the CPU time can be minimized. Similarly, the refining or partitioning, the function to be implemented into smaller interfacing pieces. So refining, a partition, I have memory. Memory has to be partitioned or interface has to be partitioned. So these are things where I could look at it. A refinement has been very, very important before you go for a major task design. And hardware software partitioning allocating elements in the refined model to either hardware units or software units running custom hardware or a microprocessor. So therefore, refined modeling of the partitioning and the hardware and software has been also important. Scheduling, the times at which the functions are executed. This is important when several modules in the partition share a single hardware unit. Okay. how to schedule, how to share the task given is been very important, which comes under the scheduling part. Then the mapping, a functional description into a software runs into a processor or a collection of customs, semi-custom, or a commodity hardware. So therefore, a mapping where the processor, which processor has to be involved, which software has to be employed, which hardware has to be employed. So these are the very important factor where I could say a mapping has to be done between the hardware and software. Okay, this is where I just think of as an introduction for the embedded system, and I request the students be in touch with me. I've been available for throughout, and you can talk to me at any time. You can chat with me. I can give my uh, email as well as a telephone number so that you can interact with me. Okay, this the briefly about the introduction part of the embedded system. If you go through this once again, you can understand very well that why an embedded system is so important nowadays, how it has been used present day scenario, and then you can see that everywhere we have been using embedded system design and programs only, and which has been day-to-day life. All the people have been experiencing the embedded system without knowing that it is an embedded system. That is important. Every day, even using a cell phone in your hand, it has been an example of an embedded system. Okay, right.